My name is Richard from Pivotal. I'm joined here by Asir.
Asir from Microsoft. I'm in the Java and Azure engineering team.
Awesome. So we're going to talk to you today about serverless event-driven Java, what that looks like. We're going to do a lot of demo and hopefully something that's interactive as well. We want to see if you can crash what Asir built so he feels worse about it. So we'll do our best to beat up his system. So event-driven, if you were in the keynotes today, you heard some pretty great stuff from Neha, from the functions and Riff, and hopefully getting a good sense of what we think about with event-driven. But you know, we see this every day. We're both from Seattle, so we start with thinking about coffee.
All the time.
And so when you do this is mostly an asynchronous transaction. You place an order with someone at the front, somebody makes it, they call you back later, usually with the wrong name, misspelled. But it's something, right? So that's usually an event-driven, asynchronous sort of process. Things like processing alone, I don't know, my process was not synchronous. I don't know about yours. If you
Asynchronous.
Yeah, so it stages along the way. It's a series of events. You know, a loan gets locked, something gets funded, things like that. That's all just normal events. And with even customer complaints, I don't start fixing something until people complain about it in some cases. So again, I'm waiting for things to trigger. And then of course, all of you, not in this session because this is going to be super compelling, but you're checking your email all the time. And so this is also, again, asynchronous, event-driven, it's pushed to you. So we see this all over the place. What's the architecture we actually have to create to support this? So what do we want from an event-driven architecture? Like, what is the sort of tech stuff we have to think about? Well, when you think about the architecture, typically you're breaking apart components, things that can scale well independently. There's usually single purpose. That's where functions are pretty cool as an idea. You think of trigger-friendly systems. It's hard to emit events if a system doesn't emit events. So I need systems that can in some way actually emit the data I need to trigger events. Typically you're thinking scalable infrastructure as you're trying to figure out, as I'm doing more events, this is bursty, it's going busy, it's not so busy. So how do I have scalable infrastructure? Something that can handle state. I might have to save data. Maybe I'm looking at a window of time and I'm looking for fraud in a series of purchasing events. So I want to look at the last 10 minutes in a rolling fashion. I need some level of state if I'm doing that kind of analysis. The storage, maybe your traditional relational database isn't the only thing you're going to use here as you're thinking about the volumes, the complexity of the data. Same with some sort of extensibility. Hey, new things come online that want new events. You know, we heard about that this morning. There's a new subscriber to the data. What are you going to do with that information? And then throughout all of this, one of the harder parts I've noticed with event-driven systems is all of a sudden, what happened to my stuff? Like, how do I tell what actually reacted to my data? How do I retrace my steps? And so you're in any sort of architectural design for event-driven, how are you being able to replay? How can you rethink what just happened? So Azure helps, no?
Oh yeah, Azure helps. You know, Neha talked about events. So when you have those events, Azure offers you a fully managed system for ingesting those events, storing the data, and also running your serverless code, right? That's all fully managed for you, so you don't have to worry about any infrastructure at that point, right? And it's global scale. Azure services are supported in 54 regions worldwide today, and we continue to add more regions as we go, right? We have a very robust functions platform, so when you bring your serverless code, you can just keep running at scale the way you actually like it. We also have a very high throughput and reliable event processing in the event hubs, and Cosmos DB also supports elastic storage, so it's your credit card is your actual limit.
Yeah.
Otherwise, it's there, right? And we also have a security, right? It's fully secure, particularly Cosmos DB, it's always encrypted data in motion, right?
Yeah.
So it's a pretty comprehensive platform for you to build your event-driven systems.
Yeah, some good stuff in there. And then when you look at how Spring and Cloud Foundry help with these architectures, look, Spring has great libraries for reactive, for stream processing. We saw that today. We're actually going to show off Spring Cloud Stream and how it works with the Azure systems as well. There's obviously a function paradigm you heard today with Knative and Riff and how we bring in this sort of paradigm to all environments, not just the great Azure environments. Of course, PCF, great for scaling. If I demand scaling in my architecture, then something like PCF is going to make life a little easier with auto-scale policies, now even powered by custom rules. So you can have custom metrics that trigger your auto-scaling. And then if you've kind of looked at Cloud Foundry 3 years ago, you would say this thing runs web apps. But it doesn't just run web apps nowadays. It runs batch jobs. It runs Docker images. It runs headless kind of processing things or scheduled tasks, streaming apps. So a good fit for a lot of those places. And then course, as much as we love ourselves some Azure, I can still run PCF everywhere, including your data center, including co-location, including all the public clouds, kind of your choice of where you'd like to run this sort of platform. All right, so what did we build here? So what did you build? I'm taking zero credit for this.
Oh, you also joined the program.
That was
so,
the emotional
yeah.
support for you.
So both of us, from coffee culture, so let's talk about coffee. Imagine there's a coffee shop, very successful coffee shop, and they are building an inventory hub system where they can visualize all the inventory coming in and all the sale that's going out, right? So in the world that Neha explained to us all, like it's all about events and events and events and events, right? So imagine this coffee shop, it's up and running in Boston, it's also running in London. So today what we will do is we will expand live from here into Singapore. But I do want to explain 3 or 4 things that I want to point out in this architecture. The first one I want to point out is the data ingestion or the event ingestion, right? Here you can see event hubs, right? It is at the center where all the events are fully ingested, right? And it's a fully managed. We're using that for receiving transaction and notifying as well. Now, the Event Hub also supports Apache Kafka. So any tool that you have, we can use, and that's what I'll be showing you in the code as well today. Now, the second piece is the serverless code, right? You can see the point of sale, point of intake, the updating inventory and notifying. Everything is a piece of code that's triggered by an event at scale across the globe. The third piece is the data we have, right? The data is the Cosmos DB at the center. Later, Richard will explain a little bit about Cosmos DB, but here it's a managed NoSQL database that's replicated across the globe, and it's closer to your users, and it's closer to wherever the right operation that is happening. And the fourth piece is we have dashboards, right? They're all sitting in the front. They're nothing but a Spring Boot app, and it's using the Spring Cloud Stream Kafka binder to bind to event hubs, and it's receiving and showing. Now, that Spring Boot app can run anywhere. It can run in Pivotal Cloud Foundry or Azure App Service or Azure Container Service or Pivotal Kubernetes Service. It can run just about anywhere, right? So today we are going to show you and also expand the operations right here. And you can
Hey, you can hit these URLs and actually try to beat up this system. As we bring the new one online,
Yes.
You'll actually see the new data coming from that Singapore location. So right now live, it's pulling in data from the other ones. You're going to see this just kind of stay online and start getting events from the new one. So as Asir said, he's going to deploy an entire region while we chat here because of, I think you're using ARM templates.
Yes,
It's
ARM
a-
templates. I provisioned the resources just before we got here. It takes about 7 or 8 minutes. So we provisioned it. All we're going to deploy is the serverless code into it, which will just turn it on.
So we're going to pull some of the cake out of the oven pre-baked.
Yes.
All right, just checking.
Right. Let's go.
And then we'll dig into some of those components when he finishes the demo, kind of explaining what those pieces are and why they matter from a technology perspective, how that helps you build good event
So
systems.
you can see it up and running in Boston and London right now. That one is getting on a refresh rate. The second one is receiving it through a WebSocket. So you can see all the coffee shop events, whether they're selling something or arriving something, is actually coming live. If you use the URL that Richard was showing, you will hit the same page, right?
Just from the two locations right now,
Just
right?
from the two. One will show you the dashboard, the other one will show you the event stream that is actually coming through, right? Okay, so let's go to the code and start deploying right now. So here we have the code. So here is the function. Let me show you one function first. How about this? I come back after I start the deployment. Okay, that might be the easier one. This changed a bit because of the resolution, I
Right.
guess.
Could you make it a little bit smaller? I'm not sure the folks in the front can see it. I'm kidding. Maybe a little larger.
I'm not sure.
Yeah.
Let's see. Let's try. Is that better? And this one I'll also do a little plus. And
They'll believe you. It's a lot of green text on black, so.
I know. Okay. So this one I need to reduce a bit so it can.
Okay.
Okay, good. So I'll
you're
set the set up my environment. Where am I? Right here. So all we have to do is, at this point, deploy.
And you're just deploying the functions to Singapore.
Yes.
In real life too, right? We're not faking it. It's not down the street.
Yes.
Yeah, okay.
So I just compile my code first, right? It just packages like any other environment that we are all used to. Nothing new there. And I'll go straight for deploy from there. And while it's getting deployed, you can see the events that are streamed into the dashboard on the right-hand side. But that's a different app. On the left is where we are compiling right now. Okay. So I'll give it a second. I think it's done.
Yeah, and then you'll deploy those.
Then I'll start the deployment, and we'll start looking at some code in the meantime while it's deploying, right? Okay, it succeeded, right? So for deploying, all I have to do is MVN, Azure, functions, deploy.
Okay, so those functions will kick off.
Yes. So now while it's kicking off, we can look at the code. So let's go here. So here is, I want to show you a function. So this particular function is written using Spring Cloud Function, and it's running in Azure. So you can see, you probably recognize this is nothing but a Spring Boot application, which is represented as a function, and it's processing two POJOs. One is a transaction document, and the other one is the event that's coming through. So here is the transaction doc. If you use Lombok, it'll be very simple, and that's the event.
It's a very familiar Java stuff.
It's a very familiar Java stuff. And Dave Sawyer worked on a Spring Boot handler, which binds it to Azure, and that's the binding code where it points out what trigger and what is the output binding. So it receives an event coming through, and then it puts it into the Cosmos DB at that point, right? So it's pretty simple, and then it hands off the actual processing into the Spring code, where the Spring code builds everything, which Dave Sawyer also announced this in the blog today. Okay?
Yeah, I think we shipped it last week, so you can start messing with all this right now.
All right, I think the deployment is happening right now.
Okay.
You can see that the app does not exist, so it's creating it on the left. Okay. Okay. So similarly, we have a few other functions here. So that'll be the append transaction, and here is a notify inventory, which is also a simple function. In this case, we wrote directly as a Java code without any Spring Cloud function. We want to show you the flavor of both. Right here again, you can see secrets are completely managed. Nothing is in the code. Everything comes from the environment. Right. Let me check if the deployment has gone through.
Yeah, these are very small functions that you're able to now deploy independently, update independently. Yes. That's nice.
Right. It's deploying the function app. It's created one. At this point, it's deploying into Azure in the Singapore area.
Do we see this in the Azure portal?
Yes, why don't we see that in the Azure portal while we wait for the deployment to happen? I think it is this guy. So we have deployed in multiple regions. You can see the deployment here in Singapore, in London, and this is the deployment in the East US, right? So if I go in here, you will see all the functions that are running, the event hubs that are running right here, right? So that's how it is organized. Every region is a separate resource group. That's how we organize this one. So let's go back to the code. It's deploying.
And should we just see this hit the app when it starts working? Is that the idea?
That's it. I think the app will just, okay, it's deployed. It'll get started on the server side. So we just have to wait for the server side to kick in at this point. So if I go into the dashboard, it's right here. And the socket, you would see the events will slowly come through at this point. Singapore is coming on board.
Hey, there we go.
You can see Singapore coming on board with first one is 9 yogurt boxes arrived, looks like. And now It's increasing, the sale is increasing. You can see the the deployment come alive and the events are coming through. You can see the Singapore. If you're already logged in your phone, you would see the same thing come alive at this point. Yeah.
So by using some shared things like Event Hubs and Cosmos DB, just adding this new one, we don't have to change the dashboard. It just works.
Right.
Yeah.
We don't have to change the dashboard. All we have to do is deploy the necessary Event Hub and add the serverless code. And once the point of sale and point of intake starts coming alive, then it starts putting in events, and you can see the sale that is coming through straight from Singapore. Right?
Awesome. So yeah, let's talk about some of the components then.
Yes.
Some of the magic behind this.
I do want to show one small thing before
one more thing, Steve
One
Jobs.
more thing,
Sure.
yeah. So I want to show you the code, one piece of code. So in the dashboard, dashboard is a very simple Spring Boot app. So here is the app, and you can see that, first I'll show you that we have imported the Spring Cloud Stream code right here, right? And all we did is just turned on the stream listener and declared ourselves as the input, and then it starts receiving messages directly from the event hubs. So
that's really all there is. I mean, I'm not supposed to play favorites among my Spring kids, but like Spring Cloud Stream's the best, I think.
I think there are lots of Spring magic going on here. All you have to do is a Spring data for Cosmos DB to talk to Cosmos DB.
Yeah.
The Kafka binder for talking to event hubs, Spring Boot app, and yeah.
That's it.
That's
great.
Plenty of Spring Boot magic in play here. All right. So right here, let's go back to.
Yeah, let's talk about some of the pieces that make up that architecture, that make up probably any reasonable architecture you're going to do in an event-driven. And if you don't use the same systems or you're using a different cloud, that's technically okay. These are conceptually, though, the pieces that make a lot of difference here. So first, let's talk about Cosmos DB. Probably the most, again, I'm not supposed to play favorites. I have an Azure MVP for the last 11 years, so I'm not supposed to play favorites, but Cosmos is probably the best. I don't know. Don't tell the Service Bus guys. But when you think about what Cosmos does, Cosmos DB is a sort of planet-scale NoSQL database. It's got different interfaces, so it's multi-model is how they refer to it, so that it can do graph, it can do key value, it can do all these different kind of components. So what makes Cosmos kind of interesting is it's not just a key value store, it can be a document store, it can be these other pieces. It exposes APIs like MongoDB, like Cassandra, so it has those interfaces. So if you have code that talks to MongoDB, it'll just work with Cosmos, which is pretty neat. It has the same sort of API, same with Cassandra. But what's neat architecturally is it actually is this sort of geo-distributed global scale thing, and they just added yesterday multi-master support. So I could have masters in all the different regions around the world that are actual read-write master nodes. They do some amazing replication behind the scenes that actually make this a highly available database system. So that's pretty wild stuff. They also have additional capabilities for SLA. It's a 5 nines SLA on read and writes, which is somewhat unheard of for a cloud database. So Cosmos itself is a pretty good system to actually build this and base this on, given its resilience, given its architecture. So we were storing some key information in there, but you can use it obviously for a lot more than just what we're doing here. You can store for all kinds of data. As Asir said, the only limit is your credit limit. So if you have bad credit, Cosmos will only scale to 2 nodes, I think. The next one's Azure Event Hubs. You want to talk a little bit about that?
Yeah, so we talked about event-driven retail here, right? So the point of sale, the inventory streams, the plenty of stream processing. So it's all about data, just like the way Neha explained. We live in a world of events. So if you think from an event point of view, your software building is very, very different, right? So in the cloud, so what we use there is a fully managed event hub system. It can handle the cloud scale ingestion, whether it's a variety, a volume, or the velocity. It is fully suitable for hyperscale ingestion. Right? Now, from a Java point of view, it supports Kafka. So as long as you have the Kafka tools, you can just start using it. Right? So it's fully integrated for Java developers. It's also integrated in Azure, so you can, from other services, integrate directly with Event Hub. For example, we saw how serverless, the function code was integrated to Event Hub, so when an event arrives, how it started kicking.
Yeah. Neat stuff. You want to talk about Azure Functions for me?
Yes, Azure Functions. So in Azure, we have a fully managed Azure Functions runtime. So if you can just bring your serverless code and you deploy it, it'll start running at scale across the globe. You saw how we were able to deploy into Singapore, and you saw the events coming through. Now, Java is fully supported. You don't have to use any new tools, just use the tools that you already know, which is Maven, IntelliJ, Eclipse, or Jenkins for all the deployments. It is fully integrated with all the triggers, whether it can be triggered by any code. It's also including things like Event Hub, Cosmos DB, storage, and if you have your output binding and your input binding, they can be bound to managed data services running on Azure. We showed you how it is bound to Cosmos DB in the example.
Yeah, good. So functions are a decent part of an event-driven architecture. So Spring Cloud Function, how do you have even additional portability here? So it's important that Spring Cloud Function itself isn't a FAS. It's a framework to build the functions that go on a function as a service kind of platform. So Spring Cloud Function is a project that you can all use from start.spring.io, Josh Long's second favorite location. And you can go there and actually build these functions fairly straightforward. So what's neat is it's Spring Boot functions. I can just build Java functions, but if I like dependency injection, I like the auto configuration, I like to connect to some of those other projects to integrate together, Spring Cloud Function will do that on every public cloud. What's also neat is you can even build functions on the fly with Spring Cloud Function. I could send it in a class as a string, and it will actually compile that dynamically and run that as a function. What's also cool is that same function can do things like either be spun up from an HTTP request, so I invoke my function that way, or I can actually have it trigger in a response to a stream process. So something hits Kafka, something hits RabbitMQ, just trigger a function. And what's neat is you don't actually have to build your function to do anything special. That's really just a binding detail. So you're able to kind of decouple how you trigger the function from the function when you use Spring Cloud Function. It also stores things like a registry of the function, so it knows how to spin things up. And of course works with the public cloud functions like Azure Functions, and our teams work closely together to deal with just kind of the uniqueness of each given function platform. So you can run this on Azure, on AWS, on other clouds, or run it in your own environment. None of this requires a FAS platform. You can run this on your desktop.
So Dave, Sawyer, and Oleg, they worked with our teams to integrate Cloud Functions, Spring Cloud Function into Azure. Today we only showed you a very small example. Tomorrow there is a session by Jeff Holland and Oleg where they'll drill into how Spring Cloud Function runs in Azure. Yeah. Okay, let's move to the dashboard, right? Yeah. So the dashboard, I showed you how it was running in App Service Linux. You can also run it in Pivotal Cloud Foundry. We have instances up and running today. So we'll touch a bit on the App Service Linux. It's a fully managed app service platform. All you have to do is bring your jar or var, and it can run it at scale across the globe for you, right? Now, here again, you can use the tools that you already know, which is Maven, IntelliJ, Eclipse, and Jenkins, all those things, or you can even use your APMs like New Relic, AppDynamics, Dynatrace, all of those are available. Some of the key things it offers, it's auto scale, load balancing. You can secure your apps using Active Directory, and also does auto patching, right? So when you run Java, this morning, Jürgen Holland was talking about how you still need support for your LTS versions, right? Now, when you come to Azure, today we announced that the Java LTS support is completely free for you. So if there is any issue at the Java level, all you have to do is call Azure support. And we have established a partnership with Azure Systems so that we can deliver that to you so you can run Java anywhere on Azure.
Awesome. So this is for running a lot of these event processing systems. Of course, Cloud Foundry as well. You're at a Spring One where we talk about this a lot. You all, of course, use Cloud Foundry. You make good life choices. What is this? So it's a cloud-native platform that runs on any of your infrastructures, including Microsoft Azure. It focuses on actually getting better at just shipping software. How are we actually improving your ability there, as well as an interesting way to do security and systems management. So it's app-centric. The point isn't to spend a whole lot of time configuring infrastructure, push apps, and push Java, Node, .NET, Ruby, Go, Python, PHP, doesn't matter. Push your app. It's the same subsystems for logging and monitoring and deployment. Makes it a lot easier to not have that switching cost. What's also great is, of course, it's built to cater to Spring Boot and .NET apps, including .NET on Windows. So it's Windows and Linux underneath the covers here. And then all the automation really helps make sure you can actually operate this at scale. So all the patching is rolled through automatically of the infrastructure. A lot of really great things that mean I can have very few operators for a lot of developers. And then great marketplace, including things like the Azure Service Broker to pull in cool services. So lots of ways you can run your apps in an event-driven architecture. The key is pick one that's going to scale. If you're rushing around trying to rack and stack servers to handle your events, probably not the best way to go. So we do have a good partnership with not just you and I, but
Company.
Yeah, company-wise, we do pretty well here. So you can use PCF from the Azure Marketplace, deploy that everywhere, including even the government cloud. If you deploy PCF on Azure, it uses native services like the blob storage, managed disks for persistence. There's a really nice service broker. So if I'm building my event-driven app and I deploy it to PCF, I can connect easily to Cosmos. It's a service broker command, and it provisions a whole instance for me, gives me my credentials in the environment variables, no credentials in my code. So that service broker really does a great job of connecting me to storage, messaging, all that kind of fun stuff. If you like sucking in logs and processing them for fun, you can use the Azure Log Analytics service. And if you like single sign-on because you like your users, then you can be using Azure Active Directory to actually do that credential mapping. So that Inventory Hub project's up on GitHub. You can screw around with what we just built. It's all open source because this is now the new Microsoft too. I don't even have to ask you. You just throw it on GitHub.
Yep, everything open source.
Yeah, so as you get the slides, the links will be there for that. Java on Azure site from Microsoft's really nice. There's a whole Microsoft partner page that explains what's going on here. But the point is to build good event-driven architecture. Think of the ingest, think of the storage, the processing, the scale, and not just one piece of it. Functions alone won't give you an event-driven architecture. Kafka alone will not give you that. It's about actually how you assemble these pieces to build more responsive systems, and PCF and Azure don't do a too bad job of it. Awesome. Thank you very much for your time.
Yeah, thank you very much.